Okay, sweet. Last talk of the day. Let's do it. All right. So, hi, my name is Nicole Carlson, pronouns she, her, hers. That's my email and Twitter handle. Today I'm going to be talking to you about productionalizing a data science team. So, you may be wondering what I mean by that. When you work as a single person on a project, you can organize things however you want, or not organize things. Once you start working with more people, though, it's likely you're going to need to add some process to your workflow. So this talk is my best advice for adding that type of process. And I know thinking about process is not everyone's favorite activity, but in the long term, it will make your team more productive and efficient. So here's a nice testimonial about this from Morgan, who's in the front. She says, I'm able to experiment a lot more at work following our guidelines because it just makes it easier to organize it all in my head and get started on the actual functionality. So rather than finding it really burdensome, Morgan finds it really helpful because she can spend her time focusing on the data science work and experimentation rather than figuring out how to organize everything. So a little bit about me. I'm a former physicist, so I came from academia where you're obviously working by yourself. At my last company, Shift Gig, I was the first data scientist hired. So I was embedded in a team of software engineers for 8 months while I was the only data scientist. We slowly added more people, and by the time I left, we had 4 people. At my current company, ShopRunner, I was the second data scientist hired, arguably the first one who cared a lot about process. And over the last 2.5 years, we've grown to a team of size 10 people. So this talk is about the things I've picked up watching these 2 teams grow. So here's an overview of what I'll talk about today, some prerequisites, project management, everyone's favorite, code organization, coding standards, code reviews. The first piece of advice is you should do code reviews, model deployment, and documentation. And I just want to point out that this advice is meant to be implemented by anybody on the team. Whether you're an individual contributor or a manager or a lead, if you're excited about one of these things, you can get it started with your team. All right, so let's talk about prerequisites. The first one is pretty basic. Hire people who want to work on a team. I once interviewed someone who told me that they wanted to be a black box. They wanted to sit in a room by themselves all day, somebody would pass in data, and they would pass out predictions. Obviously, we did not hire them because they clearly did not want to work with other people. And that's fine. There are plenty of roles out there for people who want to be the only data scientist at a company. So if you're hiring for a team, reject those people and hire people who are excited about collaborating and think it's valuable. Second piece of advice, hire people with strong opinions. This is my coworker, Greg. He's really awesome. We disagree all the time, and we have the exact opposite opinions on a lot of things, but it's still super fun to work with Greg. We argue a lot, but it forces me to think a lot more about why I make the choices I do, and we respect each other a lot. So hire at least some people who are opinionated, but still willing to compromise. It's way better than having a team full of apathetic people. All right. Project management. So the most popular form of project management that many teams use from software engineering would be Agile. And a lot of people hate Agile. You can see this from this super biased poll from our coworker Michelangelo about how data scientists feel about Agile. He's obviously not very good at writing polls. Look at the 2 middle ones. They're obviously highly biased opinions. But you can see that the majority of people chose the last one. The Agile mindset is greater than the Agile process. And I believe that's true. So as you're thinking about what type of project management and workflow you need to add to your team, come up with a process that works for your team. So this is what Agile looks like for our team. So we have 2-week sprints. That's a 10 at the end behind the shadow. We do stand-ups every day, we do retros, and we do sprint plannings. So it's a modified version of Agile that works for us. It helps us figure out what each person's going to work on, how we're going to coordinate work, how we assign code reviews, and how we plan out larger projects. So in particular, this is how our Agile sprint planning works. So before the meeting, each person comes up with their own tasks. Once we're in the meeting, the group discusses each task and estimates how long we think it's going to take. I know one reason a lot of data scientists don't like Agile is because we have a lot of R&D and literature review tasks that are hard to point. On our team, we just end up time boxing them and kind of trying to give our best guess of how long we think someone's going to need to take to learn about something new. And it's fine if our guess is wrong, but we have some estimate in place. Any long-term project planning happens outside of the meeting, and whoever's in charge is responsible for getting the correct people together. And we assign code reviews after the meeting. So this is a process that works for us. It's slightly different from standard Agile. So for example, we don't have product managers writing the stories. Each person writes their own stories. And in particular, as you're thinking about Agile, you should remove parts that you don't need. So for example, we used to use user stories. So user stories are meant to be something like, as a user, I want to be able to log out of the app. For us, we ended up with all these ridiculous stories that were like, as a Hannah or a Nicole, I want to be able to do this. As a data scientist, I want my code to work. So we tried this for a couple of months, and then we were like, this doesn't make any sense. We keep ending up with these silly stories, so we're going to stop doing that. So that's just an example of one part of Agile we threw out. We don't look at burn down charts. We don't really care if stories fall out. So we just have a system that works for us. You're also going to need a place to track your work. Some place that you can see what each person is working on, what you're going to work on next, what's the overall outline of your project, so what order should you do your tasks in, what are some potential future projects if you somehow have free time, which I'm sure we all have. And finally, I think this one's really important, what requests have you gotten from other teams? So having one place to track all of that is really good. It'll make them feel heard, and you can start to see patterns in what people are asking you for. So some potential tools for this. Jira, Trello, Asana. I've used them all. They all have various pros and cons and different functionality. Most likely you're going to want to use something like this because your team probably doesn't want to spend their time building project management software. If they do, you probably don't have a team of data scientists. So here's a testimonial from our director of data science. She says, having a project tracking system like Jira has been a lifesaver. I will regularly put our current sprint side by side with our quarterly goals to check in that we're on the right track. So it can be super helpful for managers having a spot where all of this is together. And it's important for individual contributors too. So maybe if you're waiting for a code review, you can see that somebody else is working on something big. All right, let's talk about code organization. So when I talk about code organization, I'm kind of answering this question. So what's next after Jupyter Notebooks? Many of us start our projects out working in Jupyter Notebooks, or maybe when we start out as data scientists, we work exclusively in Jupyter Notebooks, and they're totally awesome. I really enjoy working with them. At some point, though, they can get kind of unwieldy as you start adding in more and more functionality. It can be hard to pass them around with your team to get people to review them. And if you're working with software engineers, they do not want to learn how to install Jupyter and open up a notebook. So at some point, you're probably going to need to pull your code out into proper Python packages. So my suggestion for that is to choose a standard repo layout and use it for all of your projects. This is the layout that my team uses. So we have a folder, that's the project name, in this case, Hermione's handbag. We have a test folder that mirrors the project folder. So if I need to know where a certain function is being tested, I know exactly where to look. And then we have a variety of files that are the same from project to project. So changelog, Docker files, requirements, et cetera. This is really useful because this means if I'm reviewing somebody else's code, I know exactly how it's going to be laid out. I know if I want to find the history of a project, I just go to the changelog and it's going to be formatted the exact same way for everyone. This is really good for new people joining your team too, especially new data scientists, because they don't have to spend their time coming up with what they think is the best way to organize a Python package. They can just copy everything from your other projects. So there are certain tools you can use to help with this, code generators. So code generators set up the scaffolding of a project for you. So you would give it, for example, your repo name, and it would set up the repo folder, the test folder, the changelog, the README, all that good stuff. So you don't have to do it by hand, and you know it's going to be uniform from project to project. You don't have to worry about somebody forgetting things. Cookie cutter is a pretty popular Python one that I think a lot of data scientists use. My company uses Yeoman. Yeoman is nice because you can write code generators in different languages, so you can be using the same tool as other engineers. So as you're organizing all your code, hopefully it's in nice, neat chunks of functionality, but you may find that there are various odds and ends that don't fit. So in those cases, I suggest you have some extra organization, common utilities repo. My current company, it's called Hermione's handbag. My last company, it was called Sonic Screwdriver. So what type of things are in this repo? So common SQL. Are you all running the same types of queries over and over again? Are you creating the same type of tables? Put it in one place. You're probably all connecting to the same databases, so you don't need to be rewriting that code in every repo. Put it in the common utilities repo. If there's any common data transformations that you know everyone needs to use with their data, put it in one place. And a variety of things maybe to help your coding. So logging helpers, unit test helpers, visualization helpers, etc. I also really like having this repo for new people joining your team. On our team, we always assign one ticket to the common utilities repo for their first or second week. They can get something implemented right away, and they learn how our team processes work. They don't have to spend their time getting their whole big project started, something that may take months. They can just immediately see how things work. All right, so your code is nicely organized now. You have it in these beautiful repos. Now it's time to think about coding standards. So what are you putting in your repos? Some examples of coding standards. How long will your lines be? Are you going to stick to 80 characters like PEP 8 says you should? Are you going to let people have infinite lines? What are you going to do? If you do set some limit, how are you going to continue long lines? Do you care if people indent in certain ways? How are you going to rate your doc strings? Do you want everyone to be doing the same thing? Are you going to use single or double quotes when you have the option? And of course, the classic tabs versus spaces. So these are the types of things I mean when I talk about coding standards. And I think it's really important to develop some for your team because it'll make it much easier for you to read each other's code and to review stuff. So here are some tips for developing your coding standards. The first is start from PEP 8. PEP 8 is the coding standard set by the Python Software Foundation. I think many people will already be familiar with it coming in. So you can start there and look at what pieces make sense to your team and what you want to use from PEP 8. Consult with software engineers at your company. If you happen to work with Python engineers, ask them how they format their code. If you can use the same standards as them, it's going to be way easier when you're working together because they'll be able to read your code really easily. So as you're looking at all this stuff, if there are cases where all or most people agree, make a rule. Just say, we're going to do it this way, and everyone has to follow it. If you decide there are cases where there doesn't need to be a rule, then I suggest that each person is consistent when they write their own code. If you're working in a file, continue all of your long lines the same way. Do the same indentation over and over again. It'll be way less confusing for other people to read if you're consistent with yourself. If multiple people are working on a project, they should agree on a set of standards for that repo. So I mentioned Greg earlier. He and I collaborate a lot. So when we work in the same project, he gets his way on some things, I get my way on some things, and we stick to them in that project. Even though when we're working in our own projects, we kind of do whatever we want. If this seems like a lot of work to try and enforce all of this, you're in luck. There are tools to help, one of which are linters. So linters are programs to automatically find code violations. So you run a linter over your code, it will tell you where your code is breaking the standard you set. So linters look for programmatic and stylistic errors. Programmatic is something like, your code tried to use an undefined variable. So for me, that's often when I have a typo. Stylistic would be things like, your lines are more than X characters long. So the linter will go through and tell you where all these errors are, and then you can go fix them yourself. If that seems like too much work, you can use an automated code formatter. So with an automated code formatter, you run it over your code, it will find the violations, and then fix them itself. Letting a computer change its code sounds like the start of a robot uprising to me, but a lot of people are into this. So a really popular tool is Black. Black is super opinionated. The authors have made a ton of choices about how things should be formatted. I think they chose wrong in a lot of cases, but a lot of people like this tool. Google has another one called YAP, yet another Python formatter. This one is way less opinionated, but you need to configure it to whatever choices your team has set. And I just want to point out, if you use one of these and not everyone on your team uses them, make sure you're not just changing your teammates' code. It's really disconcerting to get a pull request where someone has changed a bunch of files they weren't even working in because their formatter decided that the code should be formatted differently. Here's a testimonial from our coworker, Michael. He says, my personal projects now follow our team coding standards because it's painful to look at things that aren't formatted. Double quotes burn my eyes now. He's correct. Double quotes are terrible. So having these standards in place isn't a burden on people. And in fact, Michael has found that he likes using it in his own work. So it's made him a better programmer overall. All right, let's talk about code reviews. But first, a cautionary tale. So my coworker, Michelangelo, who had the Twitter poll earlier, really likes to push directly to master. When I joined our company, I was like, you need to stop doing it. It's a terrible idea. So one day, he very spitefully set up a one-line pull request. This one-line pull request was to add our new coworker, Hannah, to an authors file. Hannah reviewed this and said, hey, you spelled my name wrong. htorrent is not htorrents. Fine. I then reviewed it and said, hey, hannah.torrents.com is not an email address. You left out the @gmail. So this one-line pull request had 2 errors that required 2 reviewers to find. And this is why you should never push to master. So no matter how small your change is or how perfect you think your code is, you're wrong. It's not. There's going to be some flaw in it. So set up a pull request. Get someone to review it. There's like literally no downside to it. How many of you were taught how to review code? OK, so very few people. So code review is something that's way less common for data scientists to be taught. It's something that software engineers are taught. So that means that you need to come up with a code review process for your team because everyone's going to be coming from a different starting place. So the type of things you should answer are, how should an author prepare a pull request? So what things need to be in place before they ask a reviewer to look at their code? So do all the unit tests need to pass? Are there a number of linting errors that can make it through? All that type of stuff should be laid out beforehand. Once the reviewer has the code, how should they review the code? Are they looking for stylistic errors? Are they only looking for programmatic errors? Since we're data scientists, we often have a lot of math in our code. Is the reviewer responsible for checking that the math is correct? Or do we just need to check that the code does what it says it will do? All of this stuff should be decided for your team's code review process. And what happens when a pull request is approved? Does the author merge it in? Does the reviewer merge it in? It seems super weird, but there are places that do that. When it's merged in, does it need to be deployed in some way? All of this stuff should be codified, so there's no surprises about how people should do code review. And make sure you teach new people how your team reviews code, since it's likely that everyone's coming from a different starting place. Think about how your process might be different from other places. So we had a coworker join our team. He was super surprised to learn that we would often pull the code down locally and run the unit tests. It was really helpful for us because we caught a lot of dependency errors, but he was super surprised because his last team wasn't very thorough about reviewing code. So come up with your process and teach it to new people. Do pair code reviewing if you need to. Walk them through what the process is before they submit their first pull request so they're not surprised when they get a bunch of comments back. There are a number of tools that can help with this. So the first one that we use is a pull request checklist. So we use these in GitHub. So every time somebody opens up a pull request, they have to fill out this checklist. So they need to make sure the tests pass. They need to make sure they've described it and linked it to Jira if necessary. They need to have updated the changelog and the version, all of that type of stuff. So the author is responsible for checking all of these off before they ask the reviewer to look at the code. And this has helped us catch a lot of errors along the way by forcing people to go through this process. Another thing that can help are continuous integration tools. So this is a screenshot from Jenkins, which is a continuous integration tool that my team uses. Every time somebody sets up a pull request, these stages are run. So first, we run a linter over the code. This finds a bunch of stylistic errors. And it means that the reviewer doesn't need to go through and find all this stuff. I've learned that apparently not everyone else likes alphabetizing things, so getting a computer to do it is super helpful. If it's a Python library, we test that the import works, we run our unit tests, and we build the Python egg and wheel. So we're trying to make this as easy as possible so that the computer can catch as many of the errors as possible, so your data scientists don't have to spend as much time reviewing for this stuff. Here's a testimonial from Nate. I set up continuous integration for my personal project. I set up a linter and unit tests. Our PR process has ruined me for the better. So just like with Michael, Nate has found that he really likes our process, and he ended up using it in his own work. So people really like having this stuff in place. Let's talk a little bit about model deployment. So you have some nice model for your code, for your data, and you're ready to start getting predictions. So the hard way of getting predictions to people is this. Somebody gives you some data, you take it, you literally run to your laptop, open up Jupyter, run it through your model, you get some results back, and then you run it back to whoever requested the prediction. This is often how projects start out, and it totally makes sense in those beginning stages, or if you have a really small amount of data. At some point, however, you're probably not going to want to do things that way. Having you as a human in the loop is really inefficient, and you're going to be blocking people when you're doing things like eating and sleeping. So what you probably want to do is build a RESTful API service. So this is basically like a website people can go to. There's an endpoint where they can input their data, and then your model will make their prediction and return it. So my suggestions for building your APIs is choose one web framework for building your APIs and use the same one for all of your projects. If you're software engineers, you probably need to learn the pros and cons of a bunch of different web frameworks and choose the best one for your project. But if you're a data scientist, you don't need to do all of that. You just need to find one that works good enough for all of your problems and use that for all of your stuff. Again, if you have Python software engineers, you can consult with them, and maybe they'll be able to help you choose a good web framework. Some examples, Bottle and Falcon are really lightweight web frameworks. Django is a really heavyweight one. You're only going to use Django if you know you need Django. And then the one I'm most familiar with is Flask. It's kind of in between all of those, and if you're unsure of what to choose, I suggest Flask. It's good enough. It's probably going to be good enough for your project. All right, once you have your APIs up and running, you're going to need to support them in a variety of ways. I suggest that you spread out the burden of support amongst your team. So things you're going to need to do are probably things like load testing, monitoring, logging. If you're software engineers, you probably each need to learn how all these different parts work and be really good at it. Since you're data scientists, though, you don't need to learn all of this. Instead, each of you can learn this stuff as it comes up, and then you can share that knowledge with the team. So our coworker, Scott, needed to do load testing for one of his APIs. He found a tool called Locust. He was super excited. He got it to work. He demoed it for us. Now we all use Locust. None of us have done any other research into load testing because we don't care that much. We're data scientists. We found something that works, and we're just going to go for it. Here's a testimonial from Hannah. Our ability to deploy APIs serving model results makes it much easier to get our models tested and in front of customers. We have many examples and extensive documentation to make it easy to get started with deploying a new model. So again, we deploy all of our models the same way, so it makes it super easy. You can just copy what came before. And in fact, our process is so straightforward that one of our summer interns was able to deploy a model because all he had to do was look at another project and copy everything over. Hannah's quote also brings up documentation. That's my last point. So you should be documenting everything. I promise you, nothing bad will happen if you document everything. It's totally worth it. So document everything. Your workflow process. Did you come up with a version of Agile that works for you? Write it all down. Are there meetings? What does someone need to do to prepare for those meetings? Write it all down. Your awesome code review process that you came up with. Whatever you came up with should be documented. That way somebody can just go read about it without having to talk to their teammates. Whatever your deployment process is, you chose Flask, you have some monitoring, whatever, write it all down. It'll make things way easier for new folks. Are there instructions on how people should get access to things? So for example, maybe you know that to get access to a database, they need to talk to the data engineering team to get access to username and password. Maybe you need to get an API key by going to the AWS console, whatever. Write it all down. And I recommend that you're super explicit in your instructions. So often software engineers will assume that things in the command line are really obvious, like everyone knows how to use grep or whatever. Maybe your data scientists don't. They're coming from different backgrounds, and there's no downside to being really explicit and saying this is what you type in the terminal to get the things you want. Write it all down. I also mentioned writing it all down in exactly one place. So if you have multiple systems for documentation, it's going to be really hard to keep them up to date. You want your stuff to be documented and discoverable. So now we'll go through a few more examples. So what things should you document besides everything? Weird stuff in your data. This is an example of a product table we have at my company. You might expect that the field called description contains the product description, but you would be wrong. It is instead in a field called more_info. That doesn't make any sense. It's super weird. I happen to know it because I work with this data every day. My colleagues do not know it, though, because they're not working with this data, but it's all documented in our wiki. This way, they can figure out all the weird stuff without having to be blocked by asking me. This is also really good for new people who join your team. You don't want them to spend like a month or 2 months working on a project only for them to present, and then somebody saying like, oh, well, that data is invalid. Like, didn't you know about it? Having it all written down means they don't have to go through that. All those sweet coding standards you came up with earlier, write it all down. Your new coworkers will be able to get started much more quickly writing code, and they'll be able to write it in a way where they won't get a billion comments in their pull requests if you have the coding standards all written down. Finally, onboarding information. Every time you onboard somebody, you're going to find out that some part of the process has changed. There's a new thing they need to get access to. Write it all down. Having it in one place means you won't forget it next time. You may think that you're going to remember it, but you're not. You're wrong. So write it all down. All right, here's a testimonial from our coworker Peter. This is the first company I've worked for where the wiki pages were actually useful. You'd go to the instructions on how to set up AWS access, follow the steps, and it would actually work. So Peter joined pretty recently, and he found that this was one of the best onboarding experiences he'd had. He was able to start being productive really early on because everything was documented. So some tools, potential tools for documentation. I don't know why they're all blue. Maybe a conspiracy, who knows? So Confluence is run by the same company that owns Jira. It's a wiki, it's okay. Gitbook is having your documentation in Markdown and Git repos. I really like it because then you have access to like pull requests and branching and all that nice stuff. If you don't have access to those, just use Google Docs. Use something. Have some place to document everything. All right. I hope you have enjoyed this talk. Just a little bit of a recap. Yes, you need some process in place for your team. Whatever you choose, being consistent will take you a really long way. Document everything. It's like my favorite thing to say. And make sure you revisit your choices periodically. The process should serve your team. So that means that what works when you're a team of size 3 may not work when you're a team of size 10. So it should be constantly evolving to meet the needs of your team. All right, thanks. Questions? Any? Yeah.
I have a team of like 4 super new interns, and they're kind of doing automation data science work. We don't basically have anything set up. We have a GitHub repo, and we're kind of using a Jira board type thing. But where would you say is a good place to start? It's this is a pretty big ecosystem to build.
Yeah. So I would say to. Oh. Yeah. So he was saying that he has a team of 4 interns, and they're just getting started with adding in process and stuff. And I talked about a lot of things. So where would you start as you're thinking about tackling all of this? Honestly, I think the best place to start is whatever you're most passionate about, if it happens to be any of these things, right? So I implemented a lot of this stuff at ShopRunner, but I did it over a year. So when I first joined, I was like, hey, there's no Python coding standards. I'm going to write one, and now everyone's going to use them because I care a lot about coding standards. I wanted to use Jira, so even though nobody else on my team did, I was like, well, I'm going to use Jira just for myself. And then slowly other people started adopting it. So that's where I'd start, whatever people want. And maybe your interns are super excited about code review. Who knows? Yeah.
So you said previously when you were the only data scientist at one of your former jobs, how did you go about essentially checking that what you've put into place was actually, since you don't have anyone else to consult with or get opinions of a certain process, how did you go about getting opinions about your process that you put in place? Could you reach out to other people in the community? Would you just ask non-technical people? What was sort of your strategy to check yourself based on what you set up for your management for your work?
So I basically first just started doing whatever the software engineers were doing. Okay. And that's one reason why I'm really thorough with code reviews now, is because they would review my code, and they'd be super strict about everything, which was awesome. But I just copied what they did and then slowly adapted it as we added more people.
So from repo to repo, are you updating your setup.config or your lint.rc per repo when you're using 110 versus 100 and changing that between packages as an example?
We're not that strict about it. So we do have some older legacy packages that don't meet our current standards. But basically, we try, when somebody's working on one of those packages, they try to improve things or like make it more consistent if they can, but we know that sometimes you're too busy to do that. So we understand that things are gonna drift and we'll try to catch them up when we have time, which is never.
Any suggestion, a tool to work with a lot of data input or outputs, testing,
So
like a repo that everybody uses but has some way to standardize and, everybody knows what's there and how it's.
So the question was about some way to organize a lot of data input and output.
Yeah.
I'm not exactly sure what you mean by that. Would you not want it to be like in a?
Imagine that you run a process that needs different input files, different types, and you have a bunch of output, different types of, but you want to have kind of a organized, and maybe you run the same test different times and you don't want to override them. It could be kind of messy.
Yeah, I guess I would probably just write a bunch of scripts to handle that. I don't quite understand the use case, but maybe we can talk after. Other questions? Cool. Well, thanks for coming. You're free now.